Welcome to our class XAM250, Patterns for Cross-Platform Mobile Development. My name is Rene. In this class, we will look at dependency abstraction patterns. The idea here is that you will be able to use these patterns in order to maximize the shareable code. This is not limited to Xamarin or mobile applications. You can really use this across any type of projects that you're planning. We will have a look at three different patterns. We'll start out with the factory pattern, which you very likely have used previously, but maybe without knowing that what you were doing had a specific name. We'll then move on to the service locator, which you find in many projects out there. This is where we will learn that you actively request dependencies from within one of your components. And finally, we'll move on to what everybody is talking about these days. That's using an IOC container in order to automatically provide dependencies to an existing class. And by the end of this course, you'll be able to pick a pattern that suits best your project and your personal preferences. And you'll be able to maximize code sharing. You'll be able to better test your code because you will have less dependencies. Although you can use the patterns that you will learn today everywhere, we will focus on one specific use case. That is something that we already started in our intro class to cross-platform development, our XAM110 class. We want to see how we can call into platform-specific features from our shared code. So you might have some .NET Standard library or maybe some Xamarin Forms project, and you want to take advantage of a very specific feature that exists on a platform. Maybe you want to use Touch ID on iOS or something like that. In order to call into the platform-specific projects, you will need an abstraction. And that abstraction, that is possible to be created by using either the factory or the service locator or an IOC container. Now let's start out by looking at the factory pattern. We'll learn what a factory is, what is it used for, and how do we create such a factory. If you think back to the cross-platform development intro class, we create abstractions in order to represent some platform feature. And what you see here in this diagram is the idea of a logger component. And that logger component, well, it's gonna provide convenience methods that allow you to log messages. Maybe it's appending the current date and time, or the method that the log was called from, something like that. However, we don't want to hardwire the storage. So we want this logger to be able to maybe log to the console. We want it to be able to log to a database, to a web service, whatever. So we add an abstraction. And then we implement this abstraction for various scenarios. We could have a cloud recorder, we could have a console recorder, something like that. And this is very common. You'll find situations like this very often. These abstractions help you to make your code more versatile, more reusable. And sometimes it is simply necessary. I remember when I first got started with MVVM, I thought, wow, what a great pattern, and I created my first view model. And then in one of my view models, I was wondering, okay, now I want to delete something. I rather ask my user whether they really want to delete. So I wanted to show a message box. And I'm like, okay, I'm here in shared code. I don't have access to anything that would allow me to show this message box. How would I do that? Well, of course, the answer was to create an abstraction. We would create some message box or user interaction service, and then the individual platforms, they would provide the actual implementation. On iOS, maybe we would use a UI alert controller to bring up this message box. We decouple the interface from the implementation. Here is something like this message box problem that I just mentioned, an alert service. Every platform has got a way to notify their users. Often that's a simple message box. And here in our interface, we would just declare a method. That method says, if this is called, I expect some sort of message to be shown to the user. This message contains a title, the actual message text, and a label for the yes and the no button. And we code against this interface without really knowing what the actual implementation will be. And we really shouldn't care. So maybe the implementation is for a console app. Then the implementation would just do a console write line of the title followed by the message, and it would say type yes for a positive answer or type no for a negative answer, followed by a console read line. That would be an implementation of iAlert service for a console app. On iOS, we would have something like UI Alert Controller or UI Alert View. The problem, however, is when we say we are coding against this interface, how would we get a concrete implementation of that interface? It's nice to have this idea of, yeah, I'm just using the iAlert service interface and I call the show method. But remember, the setup of our projects, that usually dictates that our shared code, our .NET Standard library, or maybe you still have a PCL, that cannot directly reach to the platform-specific code. So somehow we need to find a solution to get access to the concrete implementation, to replace these two question marks that you see highlighted here. And the solution is to use one of the patterns that we're going to discuss today. All of these patterns are well known. You'll find them in a lot of projects out there, so it's good to know about all of them. We'll start with the factory pattern, which is a pretty basic, simple pattern, easy to implement. We'll then move on to service locator, a bit more advanced. And finally, we have a look at dependency injection with an IOC container. We'll also learn that dependency injection, although everybody's talking about it as being something magic, is really basic at its core. However, combined with something like an IOC container, it provides us with some great flexibility, and that's why it's used so often and everybody's talking about it. What is important is that you pick a pattern that works best for you. So even though majority of people says, yeah, your project won't succeed without dependency injection, well, that doesn't mean that you have to use it. If you're happy with Service Locator, then do that. If you have a project that already has dependency injection in it, then you should of course know about how this works. So that's why we're discussing them. The factory pattern has got this idea of the client going through, well, a factory. So what is the client in this scenario? It's not about client server infrastructure or something. No, client means this is the component in our code that wants to use a specific service. So the client, that would be maybe our .NET Standard library that wants to call into the iOS platform to, for example, use Touch ID features. So that's the client part. What is a service? I just used that term. Well, a service is something that provides additional functionality to our app. Like this message service, something that allows us to bring up a message box. And between these two, we then have the factory. Well, what is a factory doing? A factory is producing something. It is producing a very specific, well, thing or product. In our case, what the factory is producing is a service. So the client will talk to the factory and say, hey, I need something that allows me to pop up a message box. And the factory, it will know the concrete implementation. It will know the concrete parts that it needs to build up this service, and it returns it to the client. Which also tells us that both the client and the platform that where the implementation is taking place, they need to know the factory. So we will introduce a dependency to this factory here. Here's an example of how such a factory pattern could be implemented. And just to be clear, this is not the only way of implementing it. You could also use different interfaces. You will see this in our exercise about the factory. So this is a variation. What we have here is an abstract class, and that class is supposed to, again, show a message box or somehow ask the user for feedback. That's why we have this show method in there, which returns a Boolean, and that Boolean indicates whether the user wants to submit a positive or a negative answer. However, it doesn't have a concrete implementation. The class is abstract. So the actual factory implementation is this function that we have in there. We have a function in there that is called create, and it returns an alert service. And that alert service that we have in there returned by the create function, that will be the concrete implementation. So if we look at one of the platforms, here we have, for instance, iOS. We see that inside of our iOS project, we would implement alert service, this abstract base class, and have our show method there. And now this show method, it can of course use everything that iOS offers. So that would now use a UI alert controller. Which means if our shared code is now calling the show method, it will actually call into the platform specific code. All we still have to do is to connect the two with each other. We have to find a way to tell our shared code that, hey, here's the concrete implementation. And that's what the create function is for. That's what the factory method is for. We wire up this create function here and we tell it, well, whenever create is called, return a new iOS specific version of that alert service. And if now our shared code, if that knows, if it has a reference to the factory, it can call this create method whenever necessary, and it will return the concrete implementation. We can then call show, and this allows us to call into the platform-specific code from within our shared code. We have an exercise about that. I invite you to check out the lab materials, work through this exercise, and then come back to the video and continue. In the exercise, you applied the factory pattern to a project that was previously completely separated. We had one project per platform and then added a library to it, which now contains all of the shared parts. And this required you to add some abstraction to call into the platform-specific parts. Hopefully you saw the advantages of this approach. Maybe you also felt a bit like, I originally had a dependency, I had platform-specific implementations, and I exchanged those for a dependency on a factory. Well, that's just what the pattern requires. So this is something that we have to live with. The factory pattern means that both the client and the actual implementations, they will have this dependency. Besides that, I think the factory is a very easy to use pattern. It's easy to understand. It certainly does the job. It allows us to separate the concerns here. However, there's also this other problem that if you forget to register a dependency, if you forget to, subscribe to this create function, you will only notice at runtime. So it's a bit of a balance act, and we will see that later when we talk about the dependency injection pattern, that it's a bit different there. We will get the errors a bit earlier, but on the other hand, it is more difficult to understand. So that's why we say you should pick the pattern that works best for you. Let's now have a look at the next pattern, the service locator. The service locator has got this idea of, I like to call it a versatile factory, a factory that it can produce more than one thing. Again, we'll talk about the theory, what a service locator is, and then how to use it and how to implement one. We again have our client. By now we know what the client is. It's our shared code that wants to access something that is platform specific. Instead of having a factory for each individual service, which means you would end up with a lot of different factories if you had a lot of dependencies, we now have this one single locator instead. And the locator, it can now return you any kind of service that you need. It's like a company that does not only produce one specific good, it's like a company that does different things. So you would always go to the same company and say, okay, now I need this, now I need that. That's your service locator. The implementation of a service locator often involves some kind of registry, some type of dictionary. Here's an example of what a service locator implementation could look like. Our service locator will always have a singleton implementation. You see this here, this static instance property. And that makes sense. You will only want one service locator in your entire project. That's where every component is going to register their dependencies. You wouldn't want to think about, okay, for service A, I have to talk to this service locator. For service B, I have to talk to another one. Wouldn't make any sense. So that's why we always find this implementation are the singleton in there. And then we have some methods to register or add and get or resolve certain services. Depending on the service locator that you use, the signatures might vary a bit. Here in this example, we have always two overrides. You can either register a concrete implementation of a type, that's the object value part here, or you can just register a type, which means the service locator can not only figure out a dependency, it can also create that for you dynamically. So you register something by calling add, and you get some service back by calling resolve. Just like with the factory pattern, the registration will have to happen on the platform-specific projects. Here we see how we register an alert service. We tell our service locator, in case somebody's interested in an iAlert service, give them the concrete type myAlertService, which in this case would be the iOS implementation, since we're looking at finished launching here in the app delegate. We would find a similar line of code in our other projects. On Android, we would register the Android implementation, or we would register the Windows implementation. Our shared code can then simply go ahead and say, okay, dear service locator, resolve this specific type. And we just give it that interface. We tell it we need an iAlert service here. And because the service locator has got this internal dictionary, it will look up this type. It will figure out, yeah, something was registered. I'm currently running on iOS, for example, and it will return the concrete implementation. And from there, it's the same as before with the factory pattern. You just use this interface, you code against this interface without knowing what the concrete implementation is. So the important bit about the service locator, just like with the factory, is that our client code, it will actively request a specific service, instead of the service implementation being passed to it from an external instance. The implementation decides when a specific service is needed. The service locator pattern is pretty popular. You'll find a lot of different service locator implementations. That leads to an interesting situation. What if you want to use some component that has got service locator technology in it? In other words, it expects you to provide some dependency via service locator, but you are not using the same type of service locator in your project. Now the idea is great. You both thought of about abstraction, but still these two projects can't work together. So some smart people came up with the idea of creating an abstraction of the service locator itself, and this is called the Common Service Locator. You can find that at commonservicelocator.codeplex.com if you're interested. Many of the service locator implementations out there support it. The idea really is that you declare more or less an interface that says that every service locator must have an add and a resolve method with a specific signature. And you could then say, well, here, this is my service locator, it conforms to this interface, and then the library that you're using, it can call into your service locator. You find many different MVVM libraries out there and other libraries, not MVVM dependent, that have got service locator implementations. Also, Xamarin Forms has got one built in. It is called the Dependency Service. Again, we have an exercise. This exercise is about introducing or adding a service locator implementation. You will work on the same application. If you want to, you can completely replace the previous implementation of the factory pattern, or you could add the service locator on top of it so you can compare them side by side. Instead of using one of the many service locators that are out there, we provide you with a specific service locator implementation that you find as part of the assets of exercise number 2. This is a very basic implementation, but it's good to learn the core concepts. I invite you to do the exercise now and then come back to the video and continue. In the previous exercise, you added a service locator implementation. You had a look at the internals of the service locator, and hopefully you successfully retrieved a dependency using that service locator. You should also have seen the advantages and disadvantages of using the service locator. Just like the factory pattern, it just works. So that's great news. We can actively request dependencies whenever we need them. It's very easy to implement. I would argue that it's, I think, even easier than the factory pattern because you only have this one service locator instead of many different factories. The problem, however, is that just like with the factory, we have introduced a dependency on the service locator itself. And also, same problems with the factory. If a dependency is missing, we will only notice at runtime. It's going to fail on us saying, I'm unable to retrieve this and that service from the internal dictionary. It has not been registered. And this is bringing us already to the last part, using an IOC container to automatically inject dependencies. We will learn about an alternative to the factory pattern and the service locator, that is dependency injection, and we'll also learn how container can help us to automate the process of injecting dependencies. Of course, we'll have to discuss what does that really mean to inject a dependency. And trust me, it's really basic at its core. Please have a look at this example class that we have here, our public class data access layer. And our data access layer class has got a constructor, and this constructor has got two parameters. Notice how both of these parameters are actually interfaces, an IDB repository, an iAlert service. Let's quickly imagine what could that data access layer be about. It's maybe some sort of convenience class that helps us to bulk read or bulk write from or to some sort of repository. And it seems like, because it has a dependency on alert service, that if you delete something, if you try to delete some sort of record, it would automatically ask feedback from the user whether they really want to delete or not. Now, instead of hardwiring this data access layer to work on, let's say, a SQLite repository and to use Xamarin Forms in order to present the message boxes, this data access layer has got abstractions. It says, I'm going to work with anything that is an IDB repository. And I can present alerts using something that implements iAlert service. But here's the thing. Data access layer does not decide by itself to request a specific implementation for this IDB repository or for this iAlert service. Instead, it lets others do that. It asks whoever is using this data access layer to provide these implementations. It also offers a logger. And this is expressed by having this public iLogger property in there. Now, we can assume that this data access layer will not work unless we provide it with an IDB repository and an iAlert service, because these are parameters to the constructor. That seems kind of important. The logger property, on the other hand, that seems to be somewhat optional. We can assume that if we don't set this logger property to something specific, that our data access layer will still work. Maybe it's just not logging anything, or it will have some debug logging behavior, like it's maybe logging to the console. In other words, to create our data access layer instance, we will have to pass these dependencies to the constructor or to this property. And passing these dependencies, that is what injecting dependencies means. Injection can happen through the constructor, through properties, or to specific methods. Here's an example. If we wanted to create an instance of data access layer that worked with a SQLite repository, well, we have to provide that information. Our first parameter is a SQLite repository instance. And to show the messages, we're here using an WinRT alert service. And we want our data to be logged to Azure. So obviously we implement some sort of logger, some sort of iLogger implementation that works with Azure. And then we can just return our specifically configured data access layer instance and use it. Now, instead of manually configuring these parts, we can automate this process. And this is done by using an IOC container. So again, let's reiterate. What you see here, this is dependency injection. That's what I meant with it's really basic at its core. Now, what is now the complex part about it? What is this IOC container doing? The IOC container works a bit like the service locator in a sense that it allows us to register known dependencies. We would tell our IOC container, look here, if somebody wants an IDB repository, that should be a SQLite repository. If somebody wants an iMessage service, that should be a Xamarin Forms message service. And instead of creating our object then manually, we tell the IOC container, now create me a data access layer. And it will know by inspecting the constructor, hey, I can create something that matches IDB repository. I can create something that matches iAlert service. It can inject those dependencies and then return the completely created type to us. Let's have a look at an example how this works. We would use our IOC container and tell it to create a specific type. Here in this case, we're again using data access layer. It's important to notice that an IOC container can really create anything. If you told an IOC container to create you a string object, it would do that. It would just look at the string object, it's using reflection, it would look at the string object and say, okay, there's a constructor that doesn't take any parameters, I'm going to call that, and I'm going to return you a string object. So here we tell it to create a data access layer. It will try to do that. It's using reflection to do so. And it figures out that data access layer doesn't have a parameterless constructor, so it can't create that right ahead. Instead, it figures out that there's a constructor that has got a dependency on IDB repository. We just left out the alert service here to make the example a bit simpler. So before creating the data access layer instance, it will have a look at its internal registry and figure out, yep, somebody has registered the SQLite repository in case an IDB repository is used. So it will create that instance first. It will then go back to the data access layer constructor and via reflection pass in the dependency to the constructor and finally return the created data access layer type to us. This frees us from thinking about those dependencies. We just tell it, give me an instance of data access layer. Now, depending on the IOC container that you are using, and just like with the service locator, there are many different, partially very sophisticated implementations out there. You don't even have to register anything. Those containers can be very, very smart. They would, for instance, just to be able to create data access layer by scanning the current assembly, they would look for something that implements IDB repository. They would automatically pick that because they would assume that that's what you want to use. If we manually register our dependencies, this is what it could look like. And you see, pretty similar to the service locator. We often can register concrete types or objects and then just call the create method and tell it to return us the specific type that we're asking for. Once again, we have an exercise for you. And of course, this exercise is about using dependency injection. If you look at the exercise instructions, you'll find that we provide you with a very basic implementation of an IOC container. After the exercise, we'll have a look at what is out there, which third-party implementations can you use alternatively, because they have a lot more features. But in order to get the basic concepts, what we have in the exercise instructions will be just fine. So I invite you to do the exercise now and then come back to the video and we'll talk about the pros and cons. In this last exercise, you use dependency injection to remove this dependency on a factory or the service locator. And this is really one of the big advantages here. We don't have dependency on anything else. We just have what we call real dependencies. Using dependency injection also makes it a bit more obvious which dependencies are required. With the service locator and the factory pattern, we often end up with runtime errors because a dependency might be missing. If we're using dependency injection, on the other hand, if we want to create an instance of an object, well, we just can't create it if we don't provide the parameters. We could, of course, pass null and as the parameters, but then we know what we're doing. We kind of expect that to fail. In combination with IOC containers, it can be a bit tricky again. Because depending on how smart the container is, it can be hard to figure out where is a dependency actually coming from. It can happen that you right-click on some class, some type in Visual Studio, and you look for references, and you don't find anything. And it might be tempting to maybe even delete that type. Well, then your build will fail. Because if you have an IOC container in place that does automatic scanning, that automatically figures out which dependencies you have, it will no longer be able to create that type. So that's why it's sometimes considered to be a bit of magic, can be harder to get used to it, particularly if you are new to a project, if you're new to a team, and you might not know what is used where. The IOC container that we used in the exercise, that was pretty basic. I don't recommend to use that in any productive app. Instead, have a look at all the IOC containers that are out there. There are many third-party containers. You see a list of them: Tiny IOC, Ninjak. There's a simple IOC. Pretty much every MVVM framework has got one in there. You see MVVM Cross here as an example. All of these work with Xamarin. They are all slightly different with regards to configuring them, but they all work pretty well. Some can be configured via XML files, so you would put your registry in there instead of doing it in code. I definitely recommend to check these out and pick the one that you think works best for your project and your team. Before we end this class, I have one little flash quiz for you. Just some questions to verify what we have learned today. Question number 1. We discussed 3 different patterns: the factory pattern, the service locator, and dependency injection. There's something that is key to all of these patterns. What is it? Is it A, that they are using custom attributes, or B, that they are all containers, or C, that they are all using singletons, or is it D, that they are all using abstractions? And if you picked abstractions, that's the correct answer. We have to use abstractions in all of these cases. Here's number 2. We discussed the service locator. That was our second pattern. What was that again? Is it A, where services are found and set into properties on the client? Or is it B, where the client requests a specific abstraction through a shared locator? Is it maybe C, where the client creates the service directly? Or is this D maybe pure magic? The correct answer here would be B. It's where the client, our shared code, it requests a specific implementation, a specific service through that locator that both our client and the platforms must have access to. Number 3. To inject dependencies, the IOC container will often need to create the dependencies as well as the type that uses those dependencies. Is that statement true, A, or false, B? And that's answer A. This is true. Think back to this example with our data access layer. It wanted to create the data access layer instance. It could not do that because it detected that it first needs the IDB repository instance. So it got back, created that first, and then returned to the data access layer. So A is the correct answer. Number 4, and this is our last question. What is the best technique to manage dependencies? Is it A, using the factory pattern, or B, maybe using the service locator pattern, or is it C, dependency injection, or is it D, something that depends on the project, the team, and personal preference? And I guess any answer would be correct here. In our opinion, it's D. It depends on the project, team, and personal preference. If you feel like dependency injection is the only thing that you want to use, well then go for it. If you feel like Service Locator is an easy to understand pattern that works good for your project, pick that. If you already have factory patterns in your code, well then stick with them. There's no need to refactor everything if you're happy with them. That's it for today. I hope you enjoyed this course and learned a lot. If there are any questions, please be sure to check out our forums. Thanks for watching.